So good afternoon, everyone, and welcome back to Data Structures Theory Sessions. A day before yesterday, I believe, we had a first lecture, and we discussed about the content we are going to cover in this entire syllabus. And after that, we started unit number 1, where we've gone through a few points. This is the highlight of entire unit, where we need to discuss data management concepts. Then we will see data types, few data structures, then how we can analyze any algorithm or compare two algorithms, and the categorization of data structures like linear and nonlinear. That's the highlight or the overview of this unit. Now we started with discussion of management concepts, where we have taken few examples like we have the university student list, or maybe we have the student list of school. We compared those two because the amount of data is going to affect a lot, and what kind of operations you want to do there, that is also going to affect when you decide your data structure. Now, before we define a data structure, we need to think about what is the amount of data and what kind of operations we will perform there. And at the end, the final aim will be something like it should be the efficient program, efficient in terms of time and efficient in terms of space. We also discussed there will be a trade-off between time and space always. If you want to decrease your time, space will increase, and if you try to decrease space, time will increase. So we will always try to find out a sweet spot where we can say, okay, this is what is feasible for me. This time and this space will be feasible for me, and we'll find or we'll try to have a balanced situation in between time and space. So let's discuss now, if we want to do all those things, then how do we start and how to approach any of the problem. So we discussed that look, whenever you have been given a definition or a problem statement for which you want to find solution, you always start thinking on the data collection part. How are you going to collect your data? And put a thought on that data size and type both. What size of data there will be and what type of data it is going to be. So data collection. Now once you think, or once you have an idea, okay, I'm going to have large amount of data or small amount of data, and maybe that data will be of type integer character, and maybe I'm going to have some floating point numbers and so on. Now once you have that picture in your mind, then you start thinking on how you are going to organize it. So simply we can say, okay, for a student I'm going to have name, so character type. Enrollment number, maybe a big decimal number. Marks is going to be floating point numbers. Address, again, it's going to be character, string, and so on. So you have collected those information. This is what I'm going to store. Then you'll try to organize it. For each student, I'm going to have this data, and I'm going to have multiple students. So maybe we create a table. Table will be easier for handling part. So we'll think, okay, how do I organize this data? I'll go for table, a tabular form. So that's the next thing. But when you say, okay, this is how I'm going to, let's say, organize it, will it be feasible? for later operations? We need to think about it, because whatever first idea comes to your mind that need not be always feasible, or that need not be always efficient. You always should go for, or must go for, other thought also. एक आइडिया आपके दिमाग में आता है तो उसको पकड़ के बैठ गए, ऐसा नहीं है. आपको 3-4 और आइडिया सोचने चाहिए. You should think about other ways also. Then you compare those possible ways. 3-4 अलग अलग रास्ते आपको मिल रहे हैं. Then you compare those ways of performing your task. And then you'll come to a single approach or the solution, जहाँ पे आप बोल सकते हो कि हाँ, मैंने इतने सारे कंपेयर किए, इसमें से ये बेटर है with some reason, right? So once you have finalized that thing, after that you are going to develop and maintain your routines. That will be the third step. Once you have decided, okay, I'm going to have not the simple table. For me, it is going to be the array of structures. For student data, it's going to be not a simple table, but it is going to be array of structure. Because for one student, I'm going to have a structure, and when I say I have multiple students, I'll go for array. So जब आप इतना डिसाइड कर लेते हो, उसके बाद आप डिफाइन करोगे उसके रूटीन्स. रूटीन्स मीन्स ऑपरेशंस. What kind of operations you'll do on that data structure, array of structure. क्योंकि जब आप ऑपरेशन परफॉर्म करने जाओगे, जब आप कोड लिखोगे, देन आपको ये पता होना चाहिए कि मैं क्या एक्सेस कर रहा हूँ. Is it single dimensional array? Is it 2-dimensional array? Is it array of structure, or is it something else? Right? So you should know it. So after that, you'll go and develop your code, and then the next stage you will maintain your code. So these are the we can say basic steps, not in detail, but we should follow these steps one by one to approach to let's say solve any kind of problem. Not only software problem, but anywhere, any kind of problem you have and you want to find a solution, go for this one. It will help everywhere. So the middle point, organization of your data in a proper structure, is the key point here. Now, what is data structure then? From the perspective of this entire process, what is data structure? So data structure is a particular way of storing and organizing your data. What I say, पहले हमने ये बोला कि टेबल चलेगा, बट उसके बाद थोड़ा और एनालिसिस किया तो पता चला कि अच्छा, जो स्टूडेंट का डेटा है वो सेम डेटा टाइप का नहीं होने वाला है, तो मुझे स्ट्रक्चर चाहिए होगा. ठीक है, चलो स्ट्रक्चर में एक स्टूडेंट आ गया, एक से ज्यादा स्टूडेंट है तो उसके लिए एरे लेना पड़ेगा. सो द फाइनल स्टेज वी कम अप विथ इज array of structure. So what is data structure? It is nothing but how we store our data. So data structure is a particular way of storing and organizing your data in a computer. But along with that, आप ये भी देखोगे कि आगे जाके मुझे जो ऑपरेशंस करने हैं वो मैं आसानी से कर पाऊंगा या नहीं. Because tabular format भी चलेगा, array of structure भी चलेगा. Why we choose array of structure? Because it is easy to handle. अगर simple table बोल दिया, then there is no proper structure. भाई name string होगा, integer होगा, किसको पता है? phone number integer है, float है, big decimal है, किसको पता है? A simple table doesn't describe this thing. So the next point is, so it can be used efficiently. That's the last part of this definition. We need to store our data such a way that we can perform our operations efficiently, right? So that defines the data structure. If you have been asked what is data structure, you can, in a single line, you can have this statement. A data structure is nothing but how we store and organize our data in a computer so that we can perform our operations efficiently, right? Well, so to achieve this thing, now let us focus on the middle point here. Organization of data in a proper structure. How do we achieve that thing? So how do we select data structure then? Organization of data is the selection of data structure. So to select data structure, आप क्या करोगे? Once you have collected your data, then you are going to analyze the problem. You are going to analyze the problem. Student related data आपको चाहिए, वो तो पता चल गया, लेकिन actual problem क्या था? What problem you are about to solve or about to find a solution? Is it student management system, or is it just a result calculation system, or is it just attendance system, or it is a whole management system? Kya? What are you about to solve? So at that time you'll say you are going to analyze your problem. अगर सिर्फ attendance system बनाना है, then हर एक स्टूडेंट का डेट वाइज अटेंडेंस चाहिए होगा, राइट? अगर आपको रिजल्ट सिस्टम बनाना है तो सेमेस्टर वाइज रिजल्ट चाहिए होगा. If you want to create a software as a whole management system, school management or university management system, then you need everything, right? You have to promote student from one semester to another semester based on the result and based on the physical attendance or whatever criteria we need to define. So we will analyze our problem first, what we need, what are the constraints which are going to play a key role here. So you will analyze the problem and determine basic operations like insert, delete, search your data. Attendance insert करना है, dropout student delete करना है, maybe. You want to search particular student to call parents, right? Oh, well, these are few operations. नए स्टूडेंट को इंसर्ट करते हैं, ड्रॉप आउट स्टूडेंट को डिलीट करते हैं. These are the operations on student only. Every day we insert attendance. At the end of the semester, we calculate result. We promote student from one semester to another semester. All those are operations, and those operations are being done or are performed at a given time duration, maybe daily or monthly or quarterly or maybe half yearly. वो operations perform होंगे. जो ऑपरेशन ज्यादा परफॉर्म कर रहे हो आप, वो ज्यादा एफिशिएंट होना चाहिए, बिकॉज इट इज बीइंग परफॉर्म्ड एवरी डे, राइट? सो वी नीड टू फोकस ऑन दैट मोर. स्टूडेंट एक ही बार ऐड होगा, इंसर्शन ऑफ अ स्टूडेंट ऑन अ ईयरली बेसिस, बट सर्चिंग ऑफ अ स्टूडेंट may be done multiple times throughout a year. So the more emphasis we need to put here is the searching operation. So we need to think about what are the operations we are going to perform there. सर्च किस में आसानी से हो पाएगा? एरे ऑफ स्ट्रक्चर तो ले लिया, लेकिन उसके साथ मुझे इंडेक्स बनाने की जरूरत है या नहीं? We need to think about it. So based on these operations, we are also going to list out those ideas. Then we'll quantify the resource constraints, because index बनाने की जरूरत है, fine, but how are you going to create that index or table of content, right? अगर आपके पास enough resources ही नहीं है तो वो create कैसे करोगे? If you do not have large amount of data, then you can easily sort the student array, and then you can apply binary search. We'll see how. We do have a separate unit on that. तो आप ये भी बोल सकते हो कि अगर कम स्टूडेंट है तो आप उसको ऑलवेज सॉर्ट करके रख लो, और जब भी सर्च करना है बाइनरी सर्च अप्लाई कर लो, इंडेक्स क्यों बनाओ, right? So we'll quantify the resource constraints, data and the amount of resources, speed of your maybe minimum requirement of the software, कि भाई आप जो भी सॉफ्टवेयर बनाओगे उसको कौन सा प्रोसेसर, कितनी रैम चाहिए होगी. Those are the constraints on the resources. And then based on all these analysis, finally you are going to select one data structure that best meets your requirements. हाँ, पूरी यूनिवर्सिटी के लिए मैं सॉफ्टवेयर बना रहा हूँ. I'm gonna have 10,000, more than 10,000 students, okay, throughout or in a single year, comprising all the branches and everything, I'm going to have more than 10,000 students, and any faculty wants to search a student there. So to make it faster, I must create index, kind of index in my database. अगर मैं पूरा डेटा लोड कर रहा हूं तो हाँ, मेमोरी में इंडेक्स बनाना पड़ेगा. Otherwise, it is gonna be performed by the database. You are learning database management system also. तो DBMS subject में भी आपको ये सब आएगा. How those relational database are handling your data, right? But that's where we need to think. And then we are going to select our data structure. मान लो कि सारे के सारे स्टूडेंट्स मैंने मेमोरी में लोड नहीं किए डेटाबेस से, but still let's say if I want to perform something related to current year, and let's be more specific, a single stream, IT department, current year students data, then also it's gonna be 4 semesters at a time, and those number of students are going to be larger. If I load that data, let's say every student result data only, I don't want biodata, I just want every student CPI, then also it's gonna be large amount of data. If I do have one class each semester, 60 multiplied by 4, that's gonna be the amount of data I'm going to manage in RAM itself. इतना तो डेटा लोड करूंगा ही, और उसके अंदर अगर मुझे कुछ एनालिसिस करना है, हर एक सेमेस्टर का एवरेज रिजल्ट क्या है, that's one operation. What is the average result of each semester this year? तो वो मैं कैसे करने वाला हूँ, right? So that's where we think all those things. Now once we have finalized some kind of data structure, then the number of steps or the development steps will be something like, first we are going to find the data and operations that we have discussed. What is the data and what are the operations? Then second, we are going to finalize the representation of data. So that's the data structure. How do we represent that data? And And the last one, third one, it is going to be your implementation part. You will write your code. Until and unless you have clear picture in your mind about your data and operation, do not start implementation. void main भी नहीं लिखोगे जब तक आपके दिमाग में ये क्लियर नहीं है आपको क्या करना है और कैसे करना है. Forget whatever you have done till now. लैब में जब भी आपको एक प्रॉब्लम स्टेटमेंट दिया जाता है प्रैक्टिकल लिस्ट में से, देन सबसे पहले आप सब कुछ साइड में रख के with calm mind you are going to think what you have. आपके पास क्या है ऑलरेडी, what has been given in the problem statement. प्रॉब्लम स्टेटमेंट को 3 बार पढ़ो, अच्छे से समझो, उसमें से जो भी एक्सट्रैक्ट कर सकते हो वो निकालो. What is given? What do you have? What it is asking you to provide. फाइनल रिजल्ट आपको क्या लाना है. इनपुट एंड आउटपुट आपको पहले ये लिस्ट करना है. व्हाट इज माई इनपुट, व्हाट इज माई आउटपुट. देन यू विल थिंक हाउ एम आई गोइंग टू डू दिस. नाउ दैट हाउ क्वेश्चन विल गो थ्रू दिस एंटायर प्रोसेस. इनपुट से आपको डेटा मिलेगा, राइट? अगर डेटा मिल गया तो आप प्रोसेस उसके ऑपरेशंस भी सोच सकते हो. आउटपुट आपको ये बताएगा कि एक्चुअल में कौन सा ऑपरेशन करना है. एवरेज फाइंड करना है, सॉर्ट करना है, इंसर्ट या डिलीट करना है, सर्च करना है, व्हाट. सो आउटपुट विल गिव यू व्हाट ऑपरेशन यू नीड टू परफॉर्म. इनपुट विल गिव यू द data. Now once you have data, once you have the operations, then you can think data structure. That comes under how. How am I going to perform this? So data structure decide करूंगा, then उसके लिए code लिखूंगा, right? Go for this way and it is, I'm pretty much sure it is always going to help you. Never start coding directly. Well, so this is what the data structure is. Now, when you say that, okay, I'm going to select some data structure, then that data structure will require data type. Because at the end, you are going to store something in the memory. Now, when you say I'm going to store this data, what it is? Integer, float, character, what? So it's kind of a data type. So, well, data types is kind of a revision for you. You have seen this in previous semester also. There are two major categories of data types. We can say primitive and non-primitive. Primitive is something which is already inbuilt. That depends on the programming language. Okay. So in terms of C, we can say integer, character, float, double, short, long. All these are data types. Void, right? These are data types, and these data types are inbuilt data types. It is primitive. Using primitive data types, whatever you derive will be non-primitive data types. So using integer, we can create array, right? Maybe integer, character, float, array. Array is a non-primitive data type. We create that, we derive that. Using these integer, character, float, make it a member of structure. So structure भी non-primitive data type है. So non-primitive data types are not defined by the language itself, but we create it, we derive it. And the examples are array, but in this semester we are going to look at stack, queue, linked list, tree, graph. Those are the data structures we are going to see. नाउ अब आपके दिमाग में एक क्वेश्चन आएगा, सर थोड़ी देर में आप डेटा टाइप बोलते हो, थोड़ी देर में डेटा स्ट्रक्चर बोलते हो, तो ये स्टैक क्यू लिंक लिस्ट क्या है, डेटा टाइप है या डेटा स्ट्रक्चर है? एक्चुअली इट इज डेटा स्ट्रक्चर, but we are going to make it abstract data type. We will create those data structures और हम उसी डेटा स्ट्रक्चर को एक डेटा टाइप बना देंगे, so other users can directly use it as a data type. So we call it abstract data type. We will see what is ADT. Right, so they are simply created by using basic data types, so we call it non primitive data types. Well, let us see those data structures, or maybe those data types, how it looks. We'll start with array, and then one by one. Look, right now we are just trying to understand those data structures. We are not going in depth of those data structures, how operations will be performed, but right now we will just try to understand how it looks. Array कैसे दिखेगा, stack क्या होगा, linked list कैसा होता है. We are just going to try to understand कि भाई वो क्या हो सकता है. Now array, you all know that. What is array? It's, now we can say it's a data structure, okay, which consists of collection of similar data items. Look, similar is more important here. Collection तो है, लेकिन similar data type, similar data elements, similar data items, only then you can say it's a array. अगर similar नहीं है तो आपको structure बनाना पड़ेगा, right? Yeah, so what is array? It's a data structure consisting of collection of similar data elements. Along with that, all those elements are stored continuously in your memory. Memory allocation कैसा होगा? Contiguous. अगर आप बोलते हो कि 10 एलिमेंट एरे में है, तो 10 के 10 एलिमेंट मेमोरी के अंदर एक के बाद दूसरा कंटिन्यू मेमोरी होगी. ऐसा नहीं है कि 4 एलिमेंट कहीं पे रख दिए, बाकी के 4 दूसरी जगह पे और लास्ट के 2 तीसरी जगह पे. इट्स नॉट पॉसिबल इन एरे. सो इफ यू से आई वांट टू स्टोर 1000 elements, okay, and let's make it simple one. I want to store 1000 integer numbers, and if I say integer requires 2 bytes, एक इंटीजर को 2 बाइट की जरूरत है, तो मुझे टोटल कितनी मेमोरी चाहिए? 2000 bytes, and those 2000 bytes must be in a single block within your memory. आपकी मेमोरी, आपकी रैम के अंदर वो 2000 बाइट का एक सिंगल ब्लॉक मिलना चाहिए, तभी आप एरे ले पाओगे. अगर वो अवेलेबल नहीं है तो आपका प्रोग्राम क्रैश हो जाएगा. Okay, that's what this says. Elements in array are stored in consecutive memory locations. Now, how do we access for each element? We have index in the array, and index always starts with 0 in programming language. So how do we declare it? A data type, then a variable name, label, and then the size of your array, how many elements you want. And when you do it, you will have a single block of memory labeled with your variable name. Every element within your array will have some index, and using index, if you want to access some element, you can say variable name square bracket and then provide the index of particular element. 0th element 1 2 3 1. So marks of 0, marks of 1, marks of 2 and so on will give you the particular element from your array. Define array, this is what you have to write. 1 mark. Well, so this is what array is, a single dimensional array. 2D array, multi-dimensional array भी अब आप समझ सकते हो. But when I say array, then what are the limitations of array? Same data type. Index अगर आपको पता नहीं है तो आपको पूरा array access करना पड़ेगा to search. Well, that's okay. If you don't know the position, then anyway, whether it is array, it is linked list, कुछ भी है, आपको search तो करना ही पड़ेगा. It's okay. Same data type, yeah, fine. If there is different data type data, तो आप array नहीं ले पाओगे. Now that's the constraint on selecting array. But मान लो कि एक बार array select तो कर लिया, उसके बाद limitation क्या है? One is fixed size. When you declare your array, आपको एक constant size देना पड़ेगा. That's dynamic memory allocation. Still, it is fixed. When you allocate a memory runtime, तभी भी आपको बताना पड़ेगा कितने बाइट्स चाहिए. It is fixed. मैलोक कैलोक करके भी आप ये तो बताओगे आपको 20 बाइट्स चाहिए या 40 बाइट्स चाहिए. Still it is fixed. 20 बाइट्स ले लिए तो आपका एक एरे बन गया जो 20 बाइट्स का ही है. अगर आप उसको 20 से 30 करना चाहते हो then you will go for realloc. Realloc क्या करता है? 30 बाइट्स का नया ब्लॉक लेगा, पुराने एलिमेंट्स नई मेमोरी में लाएगा और पुरानी मेमोरी फ्री करेगा. तो ओवरहेड. So array is always fixed size. Another one, data elements are stored in a contiguous memory locations. अगर contiguous memory available ही नहीं है तो आप array नहीं ले पाओगे. कंटिन्यू, एक के बाद दूसरा, दूसरे के बाद तीसरा. मैं उसको पार्ट में डिवाइड नहीं कर पाऊंगा. 10 एलिमेंट को मैं ऐसे नहीं बोल पाऊंगा कि भाई 4 एलिमेंट एक जगह पे हैं, दूसरे 4 दूसरी जगह पे हैं. इट्स नॉट पॉसिबल. ऑल 10 एलिमेंट्स मस्ट बी इन अ सिंगल लाइन. इफ योर बेस एड्रेस स्टार्टिंग एड्रेस इज 5000, तो नेक्स्ट एलिमेंट 5002 पे, next element 5004 पे and so on. Continuous. So that's second limitation. Now आप बोलोगे सर ये limitation थोड़ी है. हाँ, it is a limitation. Nowadays you have a Blu-ray disc movie file. Original file है, कितने GB का होगा? अब आप सोचोगे कि अगर वो फाइल में हार्ड डिस्क में स्टोर करने जा रहा हूं, हर बार उतने जीबी एक साथ मिले, ये तो जरूरी नहीं है. Have you thought of or have you heard fragmentation in hard disk? Fragmentation in hard disk. Not a partition. Partition is a virtual partition. You call it drive, C drive, D drive and all. नो. समटाइम्स आपने सुना होगा कि भाई आपका सिस्टम अगर स्लो हो गया है तो कोई बोलेगा डीफ्रेगमेंट कर ले, स्पीड बढ़ जाएगी. हार्ड डिस्क को डीफ्रेगमेंट कर लो तो थोड़ी बहुत तो स्पीड में फर्क पड़ जाएगा. व्हाई? क्योंकि हार्ड डिस्क में क्या होता है, आपका डेटा हर बार कंटिन्यूअस मेमोरी मिले ये ज़रूरी नहीं है. तो वो ऑपरेटिंग सिस्टम क्या करता है, आपकी मूवी का एक पार्ट एक जगह पे रखेगा, दूसरा पार्ट कहीं और जगह पे रखेगा, तीसरा पार्ट जहां जगह मिली वहां पे डाल देगा. नाउ इट इज गोइंग टू मेक अ लिंक इन दोज पार्ट्स. फर्स्ट पार्ट जब खत्म होगा तो वहां से आपको नेक्स्ट पार्ट का एड्रेस मिलेगा. यू विल जंप टू दैट पार्ट. वहां पे जाके वो पार्ट खत्म करो तो थर्ड लोकेशन मिलेगा. दैट इज लिंक लिस्ट. वी विल सी लेटर. नेक्स्ट पार्ट इज अ लिंक लिस्ट. So operating system is maintaining kind of a linked list in your hard disk. क्योंकि एक साथ enough memory, enough space मेरे पास नहीं है, then I'll go for linked list. अब जब आप defragment करते हो तो वो क्या करता है? Fragments, आपका जो डेटा है उसके पार्ट हो चुके हैं, फ्रेगमेंट्स बन चुके हैं. डीफ्रेगमेंटेशन प्रोसेस मतलब जितने भी पार्ट अलग अलग जगह पे है एक जगह पे लेके आओ, सबको इकट्ठा करके एक जगह पे रख लो. दैट्स द डीफ्रेगमेंटेशन प्रोसेस. सो व्हेन यू डीफ्रेगमेंट योर हार्ड डिस्क, वो क्या करेगा? आपके पूरे डेटा को इस तरह से अरेंज करेगा कि जो पार्टीशन हुए हैं वो कम हो जाए. अगर सारा डेटा एक जगह पे है तो आपको जंप करने की जरूरत नहीं है, एक से दूसरी जगह पे जाने की जरूरत नहीं है. दैट विल डिक्रीज योर टाइम, so speed of your system will increase, right? So that's what array and linked list in memory. ये एग्जाम्पल हमने हार्ड डिस्क से समझा. इट्स नॉट थिंक कि ये डेटा स्ट्रक्चर जो है वो सिर्फ मेमोरी में चलेगा. ये डेटा स्ट्रक्चर कहीं पे भी चलेगा. इवन इन हार्ड डिस्क इट इज बीइंग इम्प्लीमेंटेड बाय ऑपरेटिंग सिस्टम. हम अभी के लिए सिर्फ रैम मेमोरी में अपने डेटा को मैनेज करने के लिए ये सारा डेटा स्ट्रक्चर समझेंगे. ओके, वेल, सो व्हाट इज एरे? अगर आपकी मूवी के लिए उतना उतना ड्राइव के अंदर स्पेस एक साथ है तो एक ही जगह पे मूवी डाल दो. लेकिन हाँ, जब नया सिस्टम आया तो एक साथ मेमोरी, एक साथ हार्ड डिस्क पूरा खाली ही था ना, तो जहां चाहिए जगह मिल जाएगी. एक साल यूज किया, 2 साल यूज किया, एक फ्रेंड के पास से हार्ड डिस्क आया, मूवी डंप किए, मूवी देखे, 5 मूवी पसंद नहीं आए, डिलीट किए. दूसरा फ्रेंड पेन ड्राइव लेके आया, मूवी डाले, अगेन 1-2 मूवी अच्छे नहीं लगे, डिलीट किए. नाउ व्हेन यू स्टार्ट कॉपी पेस्टिंग प्रोसेस और व्हेन यू स्टार्ट स्टोरिंग दोज डेटा, वो एक लाइन में जाएगा इनिशियली. सो पहला मूवी, दूसरा मूवी, तीसरा मूवी एंड सो ऑन. अब आपने बीच में से सेकंड मूवी डिलीट कर दिया तो वो जो स्पेस है वो खाली हो गया, बीच में से स्पेस खाली हुआ. सो इस तरह से बीच बीच में कहीं कहीं पे आपके पास छोटे छोटे प्लेसेस हैं जहां पे आप नया डेटा डाल सकते हो. यस, व्हाई? જગ્યા મળી, લોક 10 GB ની એક મૂવી હતી, એને હું આગળ લઈ આવું તો મારું કામ વધી ન ગયું? શું કામ લઈ આવું? ભલે પડી જ્યાં છે ત્યાં, નહીં વધે. We will see how. લિંક લિસ્ટમાં ખાલી પોઈન્ટર્સ મેનેજ કરવા પડશે એન્ડ ડન. હા, બટ પોઈન્ટરથી એ કામ થઈ જશે. જમ્પ કરવું એટલે શું? એક એડ્રેસ બદલવું, ડન. પછી તો હું 5000 એડ્રેસ રીડ કરું કે 4000 એડ્રેસ રીડ કરું, મારે શું બદલવાનું? 5000 ની જગ્યાએ 4000 કરવાનું, રાઈટ? એની હાઉ આઈ નીડ ટુ રીડ દેટ ડેટા. પછી હું ક્યાંથી રીડ કરું છું, મારે ખાલી એ જ બદલવું છે. ઓકે, સો યસ, defragmentation, if you search, there are multiple algorithms of defragmenting your partitions. So what it does, it analyze your entire space. તમે હાર્ડ ડિસ્કને ડિફ્રેગમેન્ટ કરો તો એ આખી હાર્ડ ડિસ્ક એક વખત એનાલાઇઝ કરે કે ભાઈ આમાં કેટલા ફ્રેગમેન્ટ્સ છે. હવે એ બધા ફ્રેગમેન્ટને ભેગા કરું તો મને સિંગલ કેટલી મોટી સાઇઝ જોઈશે, એટલી સાઇઝ ક્યાં અવેલેબલ છે કે જ્યાં હું ઓછો ડેટા હટાવું. તો એ એક ડેટા હટાવે, બ્લોક બન્યો, લઈ આવો. જે હટાવીશ એ બીજાને અફેક્ટ કરશે. So it is a iterative or recursive process. That's why defragmenting hard disk takes time. When you defragment your hard disk, it will take time, 1 hour, 2 hour, depending on your total size of the hard disk. So that is being managed by the table. It means operating system always creates a table of your drive. C drive. Look, when you go for my computer and double click on D, you have folders and files. Now that's just a link of those files and folders. And those links are being managed in some kind of a table, drive table in the hard disk. OS manage કરશે તમારી hard disk ની અંદર જ. That's the reason you have 1 TB hard disk, but you are not allowed to use 1 TB full. Even your operating system needs separate drive, and then your operating system needs few space to manage these drive tables, proper links to your files. Okay? Yeah, so let's એ તો કહું છું, એ ટેબલ શું કરશે? લિંક સ્ટોર કરશે. તો એ ટેબલને ક્યાંક તો જગ્યા જોઈશે. એ તમારી હાર્ડ ડિસ્કમાંથી જ જગ્યા લે છે. એટલે જ તમે ફૂલ 1 TB ક્યારેય વાપરી નથી શકતા. તમને વાપરવા માટે ઓછી જ જગ્યા મળે છે. હવે એ ઓછી જે મળે એમાંથી પણ ઓપરેટિંગ સિસ્ટમ ત્યાં જ સ્ટોર થઈ જાય. સો OS will take some space. પણ OS ને તમે જોઈ શકો છો ડ્રાઈવની અંદર. પણ જે ડ્રાઈવના ટેબલ્સ જનરેટ થાય એ આપણને નહીં દેખાય ક્યાં. We cannot directly access that thing. OS is handling that part, and when you go for kernel level coding, then you can access it. Learn operating system subject in next semester. Then you may come back to me. Okay. So we were discussing continuous memory allocation is one kind of limitation, because when we go for longer period of time using a system, it'll generate fragments, and once your space is fragmented, there are very less possibilities of having large amount of memory in a single place. So that's one thing. And the third one, when you say it's an array, coming to your point, adding and removing of any element is a tough process, because when I say array, it is contiguous, then I will make sure that I do not have any empty space in between. अगर पहले से कुछ बीच में से कुछ डिलीट किया तो वो खाली जगह नहीं रहनी चाहिए एरे के अंदर, कंटिन्यू होना चाहिए. So I will shift all the remaining elements to the left side. Yes, it is overhead. मेरा काम बढ़ जाएगा. That's why I'm saying adding or removing of element is tough, because shifting the elements, shifting process is required here. Now, let's say you have total 10 elements continuously, and you want to insert a new value in between. बीच में कहीं insert करना है, then again you have to shift. बीच में कहीं तो जगह बनानी पड़ेगी नई value के लिए. So we need to shift existing values. Whether you go for insert or delete, you have to shift values, and that creates extra process, creates an overhead here. So that's one more limitation of array. And all these limitations can be overcome by linked list. That's why we come up with the next data structure. Array requires continuous memory allocation. Linked list does not require it. As long as it is linked we can make a link in between data. So what is linked list? Again, it is a collection of data items. So collection or group. Okay. So what it is a group or a collection of data items. Instead of data item, we say it's a node. Huh? Yes, it can be. We'll see that in detail later. And that's why we haven't written here same data type. So even linked list doesn't require same data type. You can have different nodes linked to each other. Generally what we do, nodes are of same same type. Nodes are of same type. It's a node, but node internally can have any data, right? So a group of nodes which together represents a sequence. Sequence is important here because it is a linear data structure. एक line, एक sequence है, and there is a collection. तो एक के बाद दूसरा, दूसरे के बाद तीसरा, तीसरे के बाद चौथा, and so on. So you are going to make that link. Student 1, roll number 1 knows who is 2. Roll number 2 knows who is the third one. So इससे पहले I think मैंने ये example दिया था. One way is क्लास के अंदर हर एक स्टूडेंट को मैं रोल नंबर वाइज बिठाऊंगा 1 2 3 4 5 6 7 8 एंड सो ऑन. दैट्स काइंड ऑफ एरे. देन आई हैव इंडेक्स. 0th इंडेक्स पे रोल नंबर 1 होगा, मुझे पता है, राइट? 11th इंडेक्स पे रोल नंबर 12 होगा, आई नो दैट. So I can direct hit that data. Now in linked list what happens, I don't know where is roll number 12. मुझे नहीं पता है. तो लिंक लिस्ट में क्या होगा, मैं रोल नंबर 1 को याद रखूंगा, भाई रोल नंबर 1 कहाँ पे है, ओके हियर, फाइन. अब मैं सिर्फ इतना याद रखूंगा रोल नंबर 1 कहाँ पे है. देन आई एम गोइंग टू फॉलो अ सीक्वेंस. आई विल आस्क रोल नंबर 1 वेयर इज 2, क्योंकि उसको सिर्फ 2 पता है. ही नोज वेयर इज 2. 2 के पास जाऊंगा वेयर इज 3. 3 के पास जाके पूछूंगा वेयर इज 4. 4 के पास जाके वेयर इज 5, एंड सो ऑन. आई विल फाइंड आउट वेयर इज 11. वेल, तो आप बोलोगे सर ये तो लिमिटेशन हो गया लिंक लिस्ट का. यस, इट इज अ लिमिटेशन ऑफ लिंक लिस्ट. But linked list provides few more benefits. You need not to have contiguous memory allocation. Student को जहां जगह मिले बैठ जाए. So बाद में कोई स्टूडेंट आएगा तो मैं ये नहीं बोलूंगा भाई तेरी जगह ये है, बाकी के 50 स्टूडेंट को हटाओ, तू यहाँ पे बैठ. ये नहीं करूंगा, मेरा लेक्चर चला जाएगा. अब भाई बैठ जा, जहां पे जगह मिले बैठ जा. तेरे आगे वाला स्टूडेंट देखेगा तू कहां पे बैठा है, राइट? सो वेल, सो व्हाट इज लिंक्ड लिस्ट? इट्स अ सीक्वेंस ऑफ ग्रुप ऑफ नोड. अब ये नोड जो है, लेट अस अंडरस्टैंड व्हाट नोड इज. सो इन अ सिंपलेस्ट फॉर्म, नोड कैन हैव एनी काइंड ऑफ स्ट्रक्चर. अभी के लिए हम एकदम सिंपल नोड समझेंगे. व्हाट इज नोड? So in a simplest form, node is composed of two things: a data and a reference to the next node. A data itself, जो data आपको store करना है, and a reference to the next node. उसके बाद कौन आएगा? जैसे हर एक स्टूडेंट को खुद का नाम पता है, that's the data. And the next student कहाँ पे बैठा है, that's the reference. Every student knows name and the next student's sitting place. Name is the data, next to the sitting place is the reference. Yes? Yes, it can be. We will see when we go for non-linear data structures. अगर आप ट्री बनाते हो तो डिपेंड्स, बाइनरी ट्री है तो 2 रेफरेंस चाहिए, एनरे ट्री है तो n रेफरेंसेस चाहिए होंगे. सो अ नोड कैन हैव मोर देन 1 रेफरेंसेस. Linked list will have only 1 reference if it is singly linked list. It may have 2 references if it is doubly linked list. At the end, it is gonna be sequence. अगर आप forward sequence manage करते हो तो एक link चाहिए. Forward and backward दोनों sequence maintain करते हो तो 2 reference चाहिए. So we have singly linked list, we have doubly linked list. Okay? That's there is no tertiary linked list. It becomes tree. Okay? Yeah. So what is node? A node will look something like this. It will have 2 partitions. One is the data and the other one is reference. And this structure allows you efficient insertion and removal process. क्योंकि अगर नया नोड इंसर्ट करना है तो आपको सिर्फ रेफरेंसेस मैनेज करने हैं, किसी को उसकी जगह से हटाना नहीं है. No shifting process is required. Only you update references. We'll stop here for today, and tomorrow or maybe in the next lecture we will see how linked list will look. Okay, so thank you everyone for being part of this session, and hopefully everyone will come in the next lecture and we'll see what is linked list. Thank you. Online students may leave. Thank you.